Hey, C here from Digital C Studios. Welcome to the first devlog for my game engine, Ocean Engine. First, let's break down why I'm making an engine in general. A lot of game engines that are out there right now, they're very bloated and filled with features that I'm never going to end up using. I want to create a 2D top-down RPG. There are engines out there that could handle that, but they would come with features that I would never need or want. Now, I can already see what a lot of people will say. Why not use RPG Maker? Well, RPG Maker is a viable candidate, except for the fact that it feels really clunky whenever I have to use it. I also want to make an action RPG, and while that is possible with their event system, or even using JavaScript, which they allow use for as well, it just doesn't work the way that I want it to work. This has led me to create my own engine. However, I'm not starting from scratch with OpenGL and Vulkan. What I'm going to be using is MonoGame. The MonoGame framework is the same framework that was used to make games like Stardew Valley and Celeste. While MonoGame does contain support for 3D, which is something I won't be using, I still feel like it's small enough that it's worth this little bit of bloat. Add on the fact that I don't want to spend months handling rendering and shaders using something like OpenTK. MonoGame is just the best option for me. Why don't I just leave C# behind? Well, it's cross-platform out of the box, and that's why I went for MonoGame. Plus other languages like C and C++ that I don't have enough experience with them at the moment. I will be using a few other libraries along the way, and these can all be found in the description below, so you can check them out there. While you're down there, please leave a like and subscribe to keep up to date with what I'm doing. Now then, let's get started. The first thing that I needed to do was set up the project. This is actually two different projects. One of them is the engine, and another way is another project to test it. The engine project is built as a DLL file, and this contains everything the actual engine will do. The second one is just a test game that will be used to test everything within the engine. Once these are created and our sandbox project, which is our test project, is referencing Ocean Engine, it's time to get to work on the entry point. The entry point is, as the name suggests, it's the point of entry for every application. This is the class that the program class will call to initialize everything within the engine and get the application actually started. Part of this involves creating another class called Engine Globals, where we'll store things throughout the engine like the camera and the asset porter. Right now it's used to store the sprite batch, the graphics device and its manager, content manager, as well as the color for the background when the renderer clears. This will later be moved into like a level system, so then that way different levels can have different backgrounds. Once the entry point is set up, it's time to work on the ECS or Entity Component System. The best way to look at this is the way that Unity handles game objects and mono behavior. However, mine are called game entities and game scripts. The game script has a tick and render method that can be overridden, while the game entity stores each script, as well as its name or a universally unique identifier or UUID. The reason why we use UUIDs is because then it's easier to actually grab the scripts from within other scripts later on. However, there's no point of having game entities if there's no way to actually try and show them or actually tick them. So we need a scene system. This consists of a class called the Scene Manager, where everything in it is static. It stores a scene that's currently being run, and it ticks and it renders it. This is all this does. The scene class currently holds all of the game entities that will be rendered in that scene, and later on will contain a level that can be rendered so we can have things like tiles and animated tiles as well. The next thing that I felt like was needed for the engine was our actual visual assets. The visual assets are the sprite sheets and their sprites, as well as the tile sets and their tiles. Thankfully, these are basically duplicates of the same classes. The sprite sheet takes in the path of the file and then saves it as a texture, while the sprite itself has a reference to the sprite sheet as well as its X and Y position in the sheet and its width and height of the sprite. Finally, these are used to create a rectangle that point to the exact sprite that we're referencing, and then this is just the same with tile sets and tiles. The tile set's the one that contains the raw texture, and the tile has the rectangle in it. All of these are children of the asset class. Now, this doesn't do anything, but it's just used for the next feature, the asset manager. I don't want to have multiple versions of the same asset within the project at runtime, so we're going to use an asset manager. It takes the name of the asset and the asset to store, and then it can be called from anywhere else in the project as long as it's still within the asset manager. This means that I can load all the tiles for a level, and then whenever the player enters the next level, we can remove the old tiles from storage and load in new ones. This class also contains an internal method called clear assets that's used to simply clear everything that's within the asset manager, ready for the next level to be loaded. I felt like the best thing to add in next would be a camera, and I could go and create my own, or I can use a library, and the library that I'm using for this project is Camora. It handles all of the camera code for me, and all I need to do is really call it. Again, Camora, the GitHub is in the description of the video, and while you're down there, like and subscribe, please. Now that my shameless promotion is done, for the second time, it's time to create some way to render these sprites. This is where the sprite renderer comes into play. This is one of the only pre-made scripts that will come within the engine, and it's because every possible game that would come out of this would need a sprite renderer. The sprite renderer is a game script that simply takes in a sprite, and then when the sprite isn't marked as null, it renders it to the position on the screen. I do have plans to, in the future, update the sprite renderer so that it will have things like rotation and scaling, as well as changing the color of the sprite. Once the sprite renderer was complete, I wanted to test out what I'd made so far, so I grabbed a sprite sheet from an asset pack that I bought last year, and I created an object and a scene to test what I had so far, and it all came back as a success. I had a player rendering to the screen. Now I wanted to be able to actually do things with this player, so I added WASD input for moving the player around based on said input. However, I needed to make the camera follow the player as well, so it simply has the same position as the player, but I added half of the size of the player sprite, so in this case 16. During this time, I also set the size of the window to be 1280 by 720, as well as turning the project from a Windows application to a console application. This simply gave me access to the console so I can log any information as I went along. With this done, the player can now move around the world. But what was the point of a world if there was nothing to see in it? So I had to create a level class. I built this to be somewhat abstract so it can be used later on and adapted. The basics of the level class though is that it contains a struct called level layer. This contains the tiles for one of the layers of the level. After that, there's an enum that determines where the layer is rendered. At the moment, the engine only supports 6 levels: a bottom layer, a bottom decoration layer, an entity layer, an entity decoration layer, a top layer, and a top decoration layer. While this seems slightly limited, when used correctly, I feel like this is enough to create some amazing levels. This does, however, require me to start Y-sorting tiles against entities within the world, but that's an issue for later on. The level class also contains some basic functions to set tiles and fill rectangles of tiles, but these are mainly used for testing or if I decide to make like a 2D Minecraft in the future or something. To test the level class out, I created a second class called basic level, and this right now is just to be simply testing out the level. This will change later on when I have a level editor. I created a simple 5x5 world with a grass tile that I generated in paint.net, and the final result showed me that the level class was working perfectly. I decided to change this to a 32x32 tile world with 4 different tiles, and everything worked perfectly again. The second to last thing I wanted to work on was serialization and encryption. Now, I feel like using AES may not be the best way to encrypt it. I don't really understand how creating binary files works. If you have any suggestions for resources, please leave them in the comments below. Serialization is done through a system I developed a few years ago where all of the data is stored in a dictionary with string labels and objects. Then they're converted into JSON using Newtonsoft JSON. Again, link in the description. Once it's a JSON string, if specified, the file is encrypted and then written to the specific path. The final thing I wanted to do for this video was get some very basic Y sorting. This is done by simply adding every enabled entity to a list, sorting it by its Y position, then rendering from front to back. This creates a very basic Y sorting method. I haven't fully tested this out though, and this doesn't work for tiles yet. That is a later thing to do, but it seems to work for now. And that basically ends off everything that the engine can do right now. Realistically, I could create a game with this right now, but it's missing things like collisions, audio sources and categories, triggers, timers, and even UI. I also plan to create a main menu of sorts for the engine. Think like the Source SDK menu, but for the Ocean engine. However, that's for the future. For now, it's time to close off this video and say goodbye. Remember, if you enjoyed, leave a like and subscribe. Leave a comment for features you'd like to see me add, as well as any advice that you might have or resources for creating binary files. And don't forget to check out the libraries that I've used, which are linked in the description. And until next time, see ya.